Let's do an example with domain restrictions. So I have a function, x minus 2 squared plus 1, and I want to find the inverse given that in the first example, the domain restriction is all x's greater than or equal to 2, or in other words, the domain is 2 comma infinity. And then in the second part of this example, I have the exact same function, but the domain is all x's less than or equal to 2, or the domain is minus infinity comma 2. We'll see that the solution to both of these examples, A and B, are quite similar. Before I solve this, I'd like to elaborate a little bit about why the domain restrictions are what they are. So this function, f of x, x minus 2 squared plus 1, is a transformation of the quadratic function. It is a transformation which is 2 units to the right and 1 unit up. So, drawing a very, very rough sketch, it might look something like this. Now, this is not a one-to-one function because it fails the horizontal line test. And so I need to delete half of this function in order to create a one-to-one function if I want to find the inverse of a function. There are a couple of reasonable choices to restrict the domain, that is, to delete part of this function. You could delete the left half, and now this function is only defined for x is bigger than or equal to 2. In this case, we get the example in part A, or the other reasonable thing you can do is delete the right half, and now this function is defined for x is less than or equal to 2, and we get the problem in part B. Now that we talked a little bit about why the domain restrictions are what they are, let's go ahead and work on the solution. We'll follow the same ideas and principles that we've previously discussed. We will set f of x equal to y, x minus 2 squared plus 1 equal to y. Then we'll solve for x. In order to solve for x here, I'll subtract 1. So I get x minus 2 squared equals y minus 1. And then I will take the square root, more specifically plus or minus the square root, to get the x minus 2 by itself. And then I'll add 2 to both sides. So the end result is that x is equal to 2 plus or minus the square root of y minus 1. Now it's this point where the domain restriction is important. In the first example, in part A, we need x values that are bigger than or equal to 2. So we're going to use the plus. But in the second example, we need x values which are less than or equal to 2. So we'll use the minus. So for part A, we'll have that x is equal to 2 plus the square root of y minus 1. And then we'll go ahead and switch y and x. So we get that y is 2 plus the square root of x minus 1. And this will be our inverse function. F inverse of x for part A is equal to 2 plus the square root of x minus 1. Now for part B, we would do something very similar. Now I'm not going to repeat all the steps, but you would have to start at the first step here, which is setting f of x equal to y. Then you would subtract 1 from both sides, take plus or minus the square root, and then instead of taking x to be 2 plus the square root of y minus 1, you would take x to be 2 minus the square root of y minus 1. And then finally, we would switch y and x, and we would end up with f inverse of x equal to 2 minus the square root of x minus 1. So we have two very similar problems here that highlight the difference in solutions when you take one domain restriction over another domain restriction.